Hi, my name is Patrick Grady, and I'm presenting our work, ContactOpt. When people interact with their environment, they typically use their hands to manipulate objects. Thus, it's critical for a computer to be able to track the hand and object together. Prior works have attempted to address this problem of hand-object pose estimation. The task is made difficult due to the significant occlusion and high relative pose accuracy required. This example demonstrates how hard the task is. On the top is the ground truth from the HO3D dataset, and on the bottom is the result of a recent RGB pose estimator. The grasp is not physically plausible, with both large gaps and interpenetrations between the hand and object. When focusing on the ground truth annotations for the dataset, errors are still visible. Even with high-quality sensors that are used for annotation, and as the poses are more accurate, still clear gaps are visible between the fingers and the object. This is not realistic, and the object would just drop out of the hand. In the task of hand-object pose estimation, achieving millimeter-level accuracy is required for visually satisfying poses. We argue that reasoning about contact is an effective way to alleviate the problems mentioned. Contact fundamentally describes an interface between two shapes, and it can be used to easily resolve these types of pose errors. Additionally, contact can be used to inform pose estimation. For example, from only the contact map of this hammer, it's possible to estimate how it was grasped with reasonable accuracy. We introduce ContactOpt, which reasons about hand and objects through contact. Our approach has 3 steps. First, we use an off-the-shelf image-based pose estimator to generate an initial inaccurate pose. Next, we use a neural network to infer regions of target contact. And finally, we have an optimization loop to adjust the pose of the hand to enforce this target contact. Let's dive into how this works, starting with the contact inference network. The goal of this is to estimate areas of likely contact if the hand and object were aligned. We use a point net-based architecture to estimate a target contact value for each vertex on the hand and object. Since the network uses geometry rather than images as input, we find that it transfers well between domains. In order to train this network, we use the recently released contact pose dataset. This dataset uses a thermal camera to capture the heat imprint left on an object after a grasp. This allows capturing a high-resolution contact map. After contact inference, the optimization loop adjusts the pose of the hand to actually achieve this target contact. We develop a method to estimate contact maps based on the current hand and object pose. We used a distance-based method where nearby hand and object vertices are marked as in contact. This function is differentiable. We implement this differentiable optimization using PyTorch. The loss function minimizes the difference between the target contact and the current contact. The loss function minimizes error for both hands and objects, and also has a penetration factor to discourage when the shapes intersect. Next, we show some results. We perform an evaluation where we use ContactOpt to refine the poses generated by a baseline RGB pose estimator. We use the HO3D dataset for evaluation. The initial poses have significant error. The contact inference network estimates target contact maps. Next, the pose of the hand is optimized to achieve this target contact. In addition to being more physically plausible, the refined hands are also closer to the ground truth poses. When hand contact is averaged over the entire dataset, we find that, before applying our method, average contact is diffuse due to the inconsistent alignment between the hand and object. However, after applying ContactOpt, normal grasping patterns appear on the hand. We show that our approach is able to increase the accuracy of the pose estimator and reduce the kinematic error by more than 15%. Additionally, we perform a user study asking participants to compare the poses before and after ContactOpt. We find that they prefer the refined poses more than 85% of the time, showing that the refined poses are much more visually satisfying. Thank you, and please see our website and paper for further details.